This tutorial is all about triangle congruence or about congruent triangles. So we are using this software named GeoGebra, and let's proceed to the tutorial. Okay, so I prepared here earlier and text and drawings of triangles. So this topic is all about triangle congruence, and the definition states that two triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. Okay, so let's use this pen. Okay, this is triangle ABC. Okay, this is triangle ABC. This is triangle DEF. This is triangle DEF. Okay, so these are these two triangles can only be said congruent if the side here, side AB, is the same with side DE, and the side AC is the same with side BF, and this side BC is the same with side EF. Okay, at the same time, angle D is also congruent or the same to angle E, while angle A is the same or congruent to angle D. Angle D. This is angle D. Okay, and at the same time, angle F is the same or congruent to angle C. Okay, this one here. It's not actually 90 degrees, but that is just illustration of congruence. This angle here, okay. So these two triangles can be said congruent if their sides and their angles are congruent. So congruent to angle C. Okay, this one here. It's not actually 90 degrees, but that is just illustration of congruence. This angle here, okay. So these two triangles can be said congruent if their sides and their angles are congruent. So we can say that triangle ABC is congruent to triangle DEF. So we have 5 theorems or 5 postulates of triangle congruence. So let's tackle them one by one, and let's start with SSS. And I have prepared here text and triangles also earlier, and let's label each one first using the pen. Okay, so this is triangle ABC, triangle ABC. Yes, and this is triangle again, triangle DEF. Okay, I'm sorry if that looks like P, but that is letter D. Triangle DEF. Okay, that's triangle DEF. So according to the side-side congruence or three sides congruence, if the sides of one triangle are congruent to the sides of the second triangle, then the triangles are congruent. What are these sides? So these sides are the side AB, side BC, and side AC. So if side AB, that's it, is congruent to side DE, and side AC is also congruent to side DF, and side BC is also congruent to side EF. That means triangle ABC and triangle DEF, that means they are congruent. So let's proceed to another theorem, that is side angle side congruence. That means the definition is if two sides of the included angle if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So if two sides, let's label the two sides. So this is one side. If, for example, if side AB is congruent to side DE and side AC is congruent to side DF, and the included angle is the angle formed between the two sides. So this is angle A should be congruent or the same with angle D. So that is side angle side congruence. You can do it on the other sides like side BC, side AB, and side EF and side DE. At the same time, angle B and angle E. So let's proceed to another theorem, and that theorem is all about angle side angle congruence. So the theorem states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So how do we illustrate that one? So let's use the pen again. So this is triangle A, B, and C. So this is triangle ABC, and this is triangle DEF. I'm sorry for my triangle, but it is actually triangle DEF. So two sides, and two angles rather. So this is angle 1. So this angle here should be congruent to angle D, and angle D also should be congruent to angle E. And the included side is the side that is formed between the two angles, that is side AB and also side DE. You can actually use this theorem to other angles also here, like for example angle A and angle C, and the included side is angle line segment AC, and you can use it also here in this triangle. So that means that triangle ABC is congruent now to triangle DEF. Okay? So another theorem can prove congruent triangles using this one. This theorem, angle side congruence. So it states that if two angles and a non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. So how do we illustrate this one? So let's label again. So this is triangle A, B, and C. And this is triangle D, E, F. Okay? This is triangle ABC and this is triangle DEF. So the statement says two angles. Okay? For example, this is the angle 1, angle C, should be congruent to angle D, and also angle B should be also congruent to angle F. So, so the non-included side of one triangle, triangle ABC, is the line segment or the side that is not formed between this angle C and angle B, or that is not formed between two angles. So it could be the line segment the side AC or side AB, or that could be equal to side ED or DE or side EF. So let's just choose side AC. Should be congruent to side DE, so that triangle ABC is congruent to triangle DEF. So the last theorem is applicable only to right triangles to prove its congruence. So, and that theorem is hypotenuse leg congruence. So it states that if the hypotenuse and a leg of one triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the triangles are congruent. So we assume already that this angle C and angle E is 90 degrees. So let's illustrate it. Um, let's use the pen. This is triangle again ABC. Let's label the triangle A, B, and C. And this is triangle D, E, and F. So if one hypotenuse and one leg, let's just choose side AC, and is congruent to the hypotenuse of triangle DEF and the side DE. So that means triangle ABC is congruent to triangle DEF. So thank you for listening to this tutorial. This is just an overview of what is triangle congruence all about and its theorems. Thank you.